that. And Alexander Kumanis. Kumanis. So, Kumanis. So,
Yes, that's
are
great.
you the presenter?
Yes, I'm the
Alexander?
first presenter, yeah.
Perfect.
So this is joint work, the three of us. Actually, the second author did the work, which is a student of ours. Sorry, yeah. Small is Namaste, Nandri. Okay. Um, so this is part of a bigger logistical ICT project we're doing, applied research in the Netherlands, trying to improve such things like productivity on sites by logistical means. We aimed at, in previous phases of the research, we aimed on two-site logistics, which is getting materials on site, to site just in time, pulled by subcontractors themselves, nightly replenishment, so they're taking care that the materials are on site, on workplaces, so workers of subcontractors don't need to carry around and can start work directly. And don't have to clean up the rubbish because it was cleaned up in the same hall at the night time, and from a consolidation center, so daily packages of work, totally programmed. So we gained some like 43% of productivity there. So that was previous phases of two-site logistics, and now in the last phases of the research, which is now ongoing, we're aiming on on-site logistics, particularly personnel. So we have been improving that work, the time share of work with a couple of percentages, and now we're aiming at walking and waiting, which is other kind of like categories of time expenditure, and trying to find a way how to reduce them in favor of work time. So reducing walking, waiting in favor of working. And we used simulation, a modeling and simulation in the BIM phase of a project, which I'll show shortly. How we went about. So it's modeling and testing via simulation whether it would make sense. Like this, okay. So in the first phase we would develop or extend a BIM model actually, and adding our project planning, which you gave a 4D BIM model, and add site planning and labor planning to dedicate it to labor movements. So what we would have then is 4D BIM modeling, which I will show shortly. What we would then do is work simulation, work sampling based on typical work days or workforce per floor, how much working, waiting and walking were in there, and by means of interventions try to hypothetical interventions try to increase the productivity rate, which is the share of work which is available per day, and the less share of time spent used on walking and waiting, walking and waiting. So before, she got a job. You have to train on this movement here. Okay, to clarify first, there's a difference in the definition between walk, waiting, and walking and waiting, which we used in our studies, compared to what we call in lean terms, which is value adding, non-value adding, and wasting time. Just a clarification before we get into the modeling. There's two references here. Alacon, again, second time today. So if you take productive time, which is the value adding time, there's lots of other types of work which you can identify and which those authors identify too, which is not in all cases are value adding, but they still work, okay? Same goes for walking and waiting. So the greenish is value adding, this would be non-value adding, and the red ones would be wasting. So you see, work is not always value adding work. Walking time is generally, something you have to do, but you want to reduce, yeah. And waiting, in most cases you want to delay it, or if you can't do anything else, you have to reduce. So we are aiming in this study on these two categories. Working time we have been addressing in the two-site logistics work we did. There you go, tube works. So how we did this, so we had the Revit model actually. We built it out with sites and identification of rooms, additional, I will show shortly, to be able to deduce walking distance. We used the software Dynamo, which is now Autodesk 2, for data script, data deduction. So from the BIM model, deduced data deduction of movement, routing, paths, etc. And added waiting time, lift capacity, staircases and all that to be able to do the calculations finally via Excel exports in Excel. Okay, so this is a modeling or extending the model. This is data deduction, work sampling if you like, and this is calculation. Here we try to see what we came up with. So this is the case project in the Netherlands. This building, 23,000 square meters. It is this is a hotel. There's commercial stuff. There's apartments and offices. There's a railway station down here. So this was a case project. We aimed at the hotel part for drywall building for testing whether the modeling can be done and whether it would work. Okay. So what we did is, now you can see here the BIM model, or the shape of the BIM model of the building. We added the workspaces where the workforce would be working. We added staircase here and elevator. We added storages, places where toilets were and lunch, etc. So identified general the places, the rooms we call them, where workforce would typically be during the day to do their job and to go to lunch and to go to the toilet, etc. So here you got lunch. The bulbs would say the time expenditure based on typical workday per location. So lunch is pretty much. This is only for the routing, by the way, so it's not for the work itself. Compared to storage and to gates and to security checks, which is here, where the elevator is here. So there's time usage, time spent plotted in the routes, we call them, to be able to assess the amounts of time used per room. And a room would be an elevator, would be a work spot, would be the lunch room, would be the toilet, etc. So we added speed of walking over stairs, for instance, horizontally and vertically, and added speeds of elevators we used, and with stops and without stops. So we had a totally modeling kind of exercise to get in all the data, or draft all the data from the BIM we knew it needed, like distances, and added all kind of data like speeds, time-related issues, and work-related issues, to be able to do the calculations, distance, time, speed, and then come up with time. So this is, well, mathematics, pretty basic mathematics actually. What we then did is locations. We had Euclidean distances on site, which is like straight lines, I would say, and on the floor, you can't see this, we had city block distances, which is around the block, because you need to go through building, and there's walls and there's entrances, etc. So we had two types of distances we had, Euclidean blue and city blocks. So Euclidean particularly on site and city blocks particularly on floors. And for the 10 floors of the building, we could now calculate all distance, all time used per spot in the building with the script. So we got all the data now to do this, actually. So we built up this data. This is the script, you can't read it, but this is Dynamo. This is our script, so here's the BIM model. So we used all kind of data here. We added data here based on database external, like personnel speed, lift capacity, lift speeds, etc. And then via the scripts and imports and exports, it could end up with 5 databases actually, which are the Excel export scripts, which we use for the calculations. Looks like this. It's simple Excel data sheets. The Dynamo exports, spits out based on the script you make. You can and the scripts are customizable, so you can do all kind of script. It's very neat software, I would say. We figured it out for this project. In the US, it's pretty known, but we didn't know it actually. So it was a first-time experience we used this. So what we did, we had the database, we had the data, we had the scripts, and now this was the tasting of the pudding, to test whether we could have 5 simulations, which is the benchmark simulation, which is the current situation. We would have 4 interventions we would do hypothetically in a modeling simulation in the model, which is extra elevator, toilets on floors, move elevators to corner, which is corner of the building, it was now in the middle, and elevator near work, so moving the elevator around. Well, some of the intervention makes sense, others don't, but it was just for testing whether it would work and whether we could calculate the interventions in time use. So this is what we did in interventions in the model. So this is modeling interventions. So now the results. I won't go through the modeling itself, but the result. So walking, which includes moving. So well, moving in the elevator. So if we did the benchmark in the 4 interventions, we found out that toilets on floors made a huge impact, for instance, on particularly vertical time in elevators and city blocks, so moving around horizontally. 5 minutes left, okay, I will manage. Yeah. So now here we could calculate through, based on all the data we got and all the distances and the speeds, what an intervention would do. And it was pretty easy to program and to put in. So you would see here that intervention 2 would work, so toilets on floors. For walking. Now for waiting, the impact was even higher because you don't have to use the elevator so much, particularly, and in the extra elevator scenario, you would basically also have less waiting for elevators, of course. And this was calculations for per floor, per workman per day, and it saved 7 plus 17 minutes, so that would be 33 minutes per day per worker per floor, average. So you would here, this is a pretty complex sheet, I would say. Here are the levels, the floors, I would say. So here is here's the benchmark. So this is the intervention, the benchmark. So you can see the benchmark, what it would take, the total travel time, we call this. This is walking and waiting together. And what the other interventions would do. So you see here the toilets on floor. You see it's a huge slash of the time used for walking and waiting. It goes from 17 till 47 minutes per floor per man per day it saves. But, well, logically the upper floors would save more than the lower floors. And the reason why this is less, there's an elevator policy, you can't use the elevator under level 5. So you need to take the stairs. So you can see that the chunk of waiting for the elevator is a huge denominator of waiting and walking and traveling and spending time on walking and waiting in general on site, on this particular site. So again, intervention 2, putting toilets on floor, which is which is an interesting intervention, I would say, would make most sense in this particular case. It wouldn't make sense maybe in another case. So what we do is check whether we would theoretically do a validation, whether we would be in the same range as the both authors were, if we would, and we were with the, so theoretically it made sense in a way that we did these interventions and that we would stay in between the bandwidths of the percentages of productive time or work time the authors would deduce based on their work. So this is theoretical validation. We're now doing empirical validation with the workforce and verification. So we're taking now actually one floor because the building is still being built. We're taking one floor and we're putting toilets on. Let's see what happens, whether we can underline these results potentially. And transferring to other buildings, because that's the interesting part of this building of this modeling exercise. It's not a one-off modeling exercise for this building. If you import another BIM model, you would be able to do the same exercise. You would be able to, or different elevators with different speeds. It's all import data which we could change, and per project we could now, in the BIM phase, because this project is already running, we could optimize where staircase, elevators and all that could or should be in order to save walking and waiting for the workforce, and thus improve the share of working time per day. So that's about it. Thank you for your attention.